Greetings, mathematicians. Here we are in investigation 3.2 using PFact, that's how I abbreviate prime factorization, to find the least common multiple. Okay, so go ahead, pause the video, write down the focus question, and then the section that says remember this. Okay, hopefully you wrote down the focus question and the remember this. So I have to remind you guys, remember when we were solving the Ferris wheel problems and there was this problem here where one Ferris wheel took 20 seconds? 20 minutes? 20 minutes to go around and then 11 minutes to go around the second Ferris wheel. And we had to find the least common multiple, but we listed so many multiples in order to find the one that was in common. Well, I'm going to show you a strategy today that avoids this problem where you're listing and listing and listing multiples until your brain is fried. We're going to use prime factorization to our advantage here. So when I teach this method, I like to think about it this way. So if you could go ahead and write this down. Ultimately, we're trying to make some new friends. When you first start trying to make new friends, you usually want to try to find something you two have in common. Then, once you're comfortable with this new friend, then what's awesome about this friendship is now you can start showing them some things that are unique about yourself. Things that they might not know about, and that kind of stuff. So think about this like we're making some new friends. Let's take a look at this example of finding the least common multiple of 20 and 11. We know the least common multiple, we already know the answer to this. We know the least common multiple is 220 based on this previous work that we've done. So now let's go ahead and start with our factor trees. So I'm going to start with 20. Ask yourself, what's the smallest number that goes into 20? It's even, so automatically, smallest number is 2. The smallest number that's not 1, okay? All right, and I know that 2 times 10 brings me 20. Now I look at this 10, can I break it down even further? It's even, so yes I can. I can break that down into another 2, and 2 times 5 equals 10. I ask myself, is 5 breakable? Can I break it down into factors other than 1 and itself? No, 5 is prime. So the prime factorization of 20 is 2, 2, 5. Let's do the same thing for 11. Break it down into its factors. It's odd, so 2 doesn't go in, 3 doesn't go in, 4 doesn't go in, 5 doesn't go in, 6, 7, 8, 9, 10. Uh-oh. It looks like the prime factorization for 11 is just 1 and 11. Okay, so I circle these because they're prime. So sticking to my analogy here, we're trying to make 20 and 11 become friends, right? So let's go ahead and start with, well, what do they have in common? What prime factors do they have in common? 20 has 2, 2, and 5. And then 11 only has 1 and 11. They actually don't have that many things in common. That's okay. Let's say they hit it off anyway. By chance, they just so happen to, to be some really good friends. Now let's see what happens when we show our friends some things that are unique about ourselves. What is unique about 20? What prime factors are unique? Let me highlight this in green. The 2, 2, and 5 are unique, meaning that they only belong to the 20. They don't belong to the 11. So I'm going to write that down. So remember, we're multiplying these factors together. So I have 2, 2, and 5. That's what's unique about 20. What is unique about 11? What factors are unique to 11? What prime factors? There's 1 and 11. So I'm going to add that to my list here. So I have 2, 2, 5, 1, and 11. Let's see what happens when I multiply all of those things together. 2 times 2 is 4, 4 times 5 is 20, 20 times 1 is 20. 20 times 11 is 220. So the LCM, or the least common multiple of 20 and 11, is 220. And we just got the same answer using a different method. Isn't that amazing? That's what's so awesome about math. There's usually multiple ways to do things, but you arrive at the same conclusion. Let's take a look at some more examples. All right, we're going to find the least common multiple of 18 and 21. So first thing we have to do is start off with the factor trees. Let's find the prime factorization of 18 and 21. So 18, drawing my factor trees here, it's even, so I automatically know, hey, that 2 is the smallest prime factor. 2 times what equals 18? That's 2 times 9. Can I break down 9 even further? What's the smallest prime number other than 1 that goes into 9? Hopefully you said 3. And I know that 3 times 3 equals 9. And so I have my prime factorization, 2 times 3 times 3. Let's do the same thing for 21. The smallest number that goes into 21 that is prime besides 1 is 3. And then I know that 3 times 7 equals 21. And both of those numbers are prime. Okay, so now we've analyzed both of these numbers. Remember, they're trying to become friends. Let's take a look at what they have in common. And I'm going to highlight these in common things in yellow. So, what do they have in common? What factors do they have in common? Well, I noticed that there's a 3 here, and there's a 3 here. So they share this one factor of 3. So I'm going to write down 3 in my list of factors. Now remember, after you find what's in common with your new friend, then you can start showing each other some things that are unique about yourselves. So what factors are unique to 18? Well, 18 has this 2 and 3 that are unique. So let me write that down. So we have this 2 and 3. And remember, I'm just multiplying all of these factors together. This green 3, this one that I just highlighted, is the one they have in common. And then, lastly, we need to find what's unique about 21. That's this 7 here. All right, and then we multiply these numbers together. 2 times 3 is 6. 6 times 3 is 18. 18 times 7 is 126. So we say that the LCM, the least common multiple, is 126. As you can see, this method really shortens down the time it takes to find the least common multiple. We're going to walk through one more example together here. All right, let's take a look at this problem. Find the least common multiple of 18 and 24. So again, we're going to start with finding the prime factorization. So doing our factor trees, we already found the prime factorization of 18. So I'm just going to copy down what I have from the last problem. So I have 2 times 3 times 3. And then let's do the same thing for 24. So it's even, so automatically I know that 2 is the smallest number, the smallest prime number, besides 1 that goes into 24, and I know that 2 times 12 is 24. Think about it. Can 12 be broken down? It's even, so yes. Smallest prime number other than 1 is 2. 2 times 6 is 12. 6 can be broken down once more into 2 times 3. And there we have the prime factorization of 24. So let's take a look now let's take a look now at the things they have in common. Because remember, they're trying to become friends. 18 and 24 want to become friends. So what do they have in common? I'll highlight this in yellow to remain in my, my color coding here. So I noticed that 18 has a 2 and a 3, and so does 24. So it looks like they have a 2 and 3 in common. So I'm going to go ahead and write that down below as I start my list. So 2 times 3. So again, this 2 times 3 is what they have in common. And now I'm going to take a look at the things that are unique about each number. What's unique about 18? Well, there's one extra 3 left over. So I'm just going to go ahead and write that down. And then what's unique about 24? Well, what's left over are these 2 2s. So I'm going to go ahead and write those as well. And now, once I have everything they have in common, once I have everything that's unique about both of these numbers, let's go ahead and multiply all of these together. 2 times 2 is 4, times 2 is 8, times 3 is 24, times another 3 is 72. (72) is the least common multiple of 18 and 24. So hopefully you find this strategy useful. We are going to continue practicing this because we can also use this strategy to find the greatest common factor. All right, kiddos, I'll see you in the next video.